Srishti paid for an article using currency notes of denominations 1, 2, 5 and 10 using at least one note of each denomination. The total number of 5 and 10 rupee notes used was one more than the total number of 1 and 2 rupee notes used. What was the price of the article? So basically this is a question from data sufficiency where a question statement has been given followed by three statements. We got to figure out the right answer from the given options, meaning which of these statements would be sufficient for us to solve the given question, right? So what does it say? Srishti paid for an article using currency notes of denominations 1, 2, 5 and 10. So there are four different denominations that Srishti has, right? 1, 2, 5 and 10. Using at least one note of each denomination. She has used at least one note of each denomination. So there is no denomination which was not used. She had at least one note of 1 rupee, one note of 2 rupee, one note of 5 rupees and one note of 10 rupees. The total number of 5 and 10 rupee notes used was one more than the total number of 1 and 2 rupee notes used, right? Total number of 5 and 10 rupee notes used was one more than the total number of 1 and 2 rupee notes used. What was the price of the article? What was the price of the article? So basically we have to find out the price of this article. Look at the statements given to us. Statement 1, Srishti used a total of 13 currency notes. Statement 2, the price of the article was a multiple of 10. And statement 3, the price of the article was a multiple of 20, right? So let's find out which of these statements can give us the answer, right? First of all, understand the data given in the question very clearly, right? The question statement. We have got four different denominations. Let us assume the number of 1 rupee notes is equal to 1, right? Number of 1 rupee notes is equal to A. Sorry, not 1, A. The number of 2 rupee notes is equal to B. The number of 5 rupee notes is C. And the number of 10 rupee notes is D. So this is what we know, A, B, C, D, right? So A notes of 1 rupee, B notes of 2 rupees, C notes of 5 rupee and D notes of 10 rupees. Okay. The other point that is given in the question statement itself is that the total number of 5 and 10 rupee notes. What is the total number of 5 and 10 rupee notes? C plus D was one more than the total number of 1 and 2 rupee notes. So C plus D is equal to A plus B plus 1, right? So from the question statement we can also make out that C plus D is equal to A plus B plus 1, right? Total number of 5 and 10 rupee notes, C plus D, is one more than the number of 1 and 2 rupee notes, A plus B plus 1. So that's another point which is given in the question. And remember, whatever is given in the question is applicable for all the three statements. See, very, very important that when you're solving questions from data sufficiency, you got to follow a proper flow. I mean, you should verify only statement 1 first, then only statement 2, then only statement 3. If independently all the three statements fail to give the answer, then we will go for combinations, right? Like for example, when you are looking at statement 2 here, you should not be considering the data given in statement 1. Similarly, when you're looking at statement 3, you should not be looking at data given in statement 1 and 2 or vice versa. But then whatever is given in the question is applicable for all the three statements. So the point that is given in the question is C plus D equals to A plus B plus 1. Where C and D are the number of 5 and 10 rupee notes and A and B are the number of 1 and 2 rupee notes. So C plus D is equal to A plus B plus 1. This is applicable for all the three questions or all the three statements. Alright. Now let's first check the independent statements, right? Independent statements. The number of, again I'm repeating this point, the total number of 5 and 10 rupee notes used was one more than the total number of, so total number of 5 and 10 rupee notes is C plus D, was one more than total number of 1 and 2 rupee notes, right? Now look at statement 1 alone. Statement 1 says Srishti used a total of 13 currency notes. Srishti used a total of 13 currency notes. How does this statement help you get the answer? We are supposed to find the price of the article. The question is, what is the price of the article? Can you get the price of the article using statement 1 alone? No, not possible. Can you get the price of the article using statement 1 alone? Not possible, because statement 1 is only talking about total number of currency notes. Statement 1 says that A plus B plus C plus D is equal to 13. That's what statement 1 says. And if I use this point that is given in the question along with statement 1, what do we get? We get that, basically you have to divide A plus A, B and C and D in such a way that total is 13 and C plus D is one more than A plus B. So I can say that A plus B equals to maybe 6 and C plus D equals to 7. This is what I can say. Again, I'm using this data. I mean, if I combine this data with this data, These two statements together will give us this result, that A plus B should be 6, which means the number of 1 rupee and 2 rupee notes should be equal to 6. Total number of 1 rupee and 2 rupee notes, and the total number of 5 rupee and 10 rupee notes should be equal to 7. So 1 more than this, right? 7 is 1 more than 6. 7 is 1 more than 6. And 6 plus 7 is 13. Balanced. But will this help us get the answer? No, because there are multiple possibilities. See, A is referring to what? 1 rupee denomination. B refers to what? 2 rupee denomination. C refers to 5 rupee denomination. And D refers to 10 rupee denomination. Now, we have many possibilities here of the price of the article. Like, for example, if I have, how can you break up A and B? A plus B equal to 6 implies A can be 1, B can be 5. A can be 2, B can be 4. A can be 3, B can be 3. This can be 4, this can be 2, 5 and 1. It cannot be 0 and 6 or 6 and 0, because see, using at least 1 was given, right? So you cannot consider 0 and 6 as a solution. But 1, 5, 2, 4, 3, 3, 4, 2 and 5, 1 are all solutions. Meaning 1 rupee note, 5 2 rupee notes, 2 1 rupee notes, 4 2 rupee notes, 3 1 rupee notes, 3 2 rupee notes. Based on that, we'll get different sum here. Similarly, based on, for C plus D also, there are multiple solutions. Again, based on these solutions, we'll get a different price. Like, for example, 1 into 1 plus 5 into 2. So 1 plus 10, 11. 11 rupees here. And similarly, 2 into 1 and 4 into 2. So 2 into 1 is 2, 4 into 2 is 8. 10 rupees here and so on. We'll get different prices. And here also we'll get different. Like, what are the solutions for C plus D equal to 7? It can be 1, 6. It can be 2, 5. It can be 3, 4. Can be 4, 3. Can be 5, 2. Can be 6, 1. These are the solutions for C and D, right? C plus D equals to 7. So 1 and 6 means what? The number of 5 rupee notes is 1, number of 10 rupee notes is 6. Number of 5 rupee notes here is 2, number of 10 rupee notes here is 5, and so on. So these are all the solutions, which means there are multiple possibilities. I mean, you understand? I mean, there are many possibilities here. Like, again, what is important is, it's not just this and this. You have to take permutations, right? More permutations, like 1 and 5 can be taken with 1 and 6, or 2 and 5, or 3 and 4, or 4 and 3, or 5 and 2, or 6 and 1. Similarly, 2, 4 can be with 1, 6, 2, 4 can be with 2, 5, 1, 3, 4, 4, 3, 5, 2, and 6, 1. Then this. Then this. You understand? Look at this mess. This whole mesh shows that number of solutions that we get. I mean, such a complex mess. So 5 solutions here and 6 solutions here. 5 into 6, 30 different prices can be obtained. The price of the article, 30 different prices can be obtained. Just to give you an example, let us consider 1, 5 with 3, 4. So 1, 5 with 3, 4 means what? A equals to 1, B equals to 5, C equals to 3, D equals to 4. So 1, 5, 3, 4 means 1 into 1 plus 5 into 2 plus 3 into 5 plus 4 into 10. You understand? 1, 5, 3, 4. If you take 1, 5, 3, 4, 1 into 1 rupee, 5 into 2 rupees, 3 into 5 rupees, and 4 into 10 rupees. So this is 1 plus, this is like 1, this is 10, this is 15, and this is 40. So 11 plus 15, 26 plus 40, 66. So we get the price of the article as 66. But then there are a number of other prices possible. So will statement 1 alone give you the answer? No, statement 1 alone cannot give you the answer. Ruled out. Now look at statement 2 alone. Remember, we have to follow that flow. That's what I've told you, right? Only statement 1 has been verified so far. Now we are going to verify only statement 2. What is only statement 2? The price of the article was a multiple of 10. So what? Price of the article was a multiple of 10. There are hundreds of, again, don't consider anything in mind. Don't consider this 13 in mind. When you are looking at statement 2, only look at statement 2. And yes, of course, the data given in statement 1. Data given in question 1, question statement. So statement 2 says the price of the article was a multiple of 10. Now what are the multiples of 10? There are infinite multiples of 10. Yes or no? There are infinite multiples of 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 and so on, right? 1020 is also a multiple of 10. 4,67,840 is also a multiple of 10. Of course, the one point that is given here is in the question that C plus D equals to A plus B plus 1. Which means the number of total number of 5 and 10 rupee notes should be 1 more than total number of 1 and 2 rupee notes. But even then I think multiple solutions can be obtained, right? Multiple solutions can be obtained. So clearly 2 alone will not give you the answer. Yes or no? Can 2 alone give you the answer? No, 2 alone cannot give you the answer. right? Can 2 alone give you the answer? The price of the article was a multiple of 10. 10, 20, 30, 40, 50, 60, 70. No, there can be multiple possibilities, right? See, the only data that we have is it was a multiple of 10. Price is a multiple of 10. And then number of 5 and 10 rupee notes are one more than number of 1 and 2 rupee notes. Of course, I have to, use this equation in such a way that it should also give a multiple of 10. But I think multiple possibilities can arise there. Just try an example. I mean, I'm using statement 2 along with this point here. So we should make sure that the number of currency notes are in this equation and it should be a multiple of 10. So 1 rupee notes and 2 rupee notes. See, I should take 1 rupee notes and 2 rupee notes in such a way that the sum should be a multiple of, the sum should give me a value of 10, right? So I'm just thinking, I'm just doing a trial and error thing. I'm very clear that this will give you multiple solutions. I'm sure you are also sure that we can get multiple solutions, right? But just take an example. Like for example, for statement 2, let me use statement 2 so that we don't, I'm doing statement 2 in blue color here. So let's assume A is equal to 2, B is equal to 4. So because 2 into 1 is 2 rupees, 4 into 2 is 8 rupees. So 2 plus 4, 2 plus 8, 10 rupees. I want the multiple also to be 10, right? So I have to do it accordingly. And according to this, if A equals to 2 and B equals to 4, so A plus B has become 6. 2 plus 4, 6. That means C plus D should be 7. If C and D have to be 7, then again there are multiple. So this implies C plus D equals to 7. Again, C and D 7 I can take in multiple fashions, right? Are you able to follow? I have taken A equals to 2 and B equals to 4 randomly. But why have I taken 2 and 4? Because 2 into 1 rupees is 2 rupees, 4 into 2 rupees is 8 rupees, and 2 rupees plus 8 rupees is 10 rupees. See, if you using the denominations of 1 and 2 rupees, if you don't get a multiple of 10, then it will become difficult. You should either get a multiple of 10 or a multiple of 5. Because you understand, there is also a 5 rupee note available, right? So even if it is adding up to 5 rupees, this one 5 rupee note can be added here to make it 10 rupees. Any number of 10 rupee notes will give you a multiple of 10 only. The whole idea is to make sure that 1, 2 and 5 are used in such a way that we get a sum of 10 or a multiple of 10. So this is one case. Now C plus D equals to 7, there are multiple ways of doing it. I can say, C equals to 2 and D equals to 5, or I can take C equals to 4 and D equals to 3. I cannot take C equals to 3 because the moment I take C equals to 3, 5 rupee notes, which will give you 15 rupees. It will not be ending in 10. See, this is already ending in 10. Here if I take C equals to 3, I'll get 15 rupees, not ending in 10. And it will screw it up, right? Will not satisfy the condition. Then we can also take C equals to 6 and D equals to 1. C equals to 6 and D equals to 1. You understand? So multiple solutions are there. C equals to 4, D equals to 3, or C equals to 6 and D equals to 1. So what happens? 2 rupees into 1, 2, 4 rupees into 2, 8, 2 rupees into 5, 10, and 10 rupees into 5, 50. See, this is giving a multiple of 10. Similarly, 2 rupees into 1, so 2 plus 8 only, this is always. Then this is 40 plus 30. Right, then this is again 2 plus 8, and this will give us 60 plus 10. So 10 rupees plus 10, 20 plus 50, 70 rupees. This will give me 10 plus 70, 80 rupees. This will give me 10 plus 60, 70 plus 10, 80 rupees. So see, multiple solutions are there, right? 70 can be done, 80 can be done. And again, we have taken only one sample. There can be more and more cases there. You're able to follow. You're able to follow. There can be more and more cases. So basically the point is statement 2 alone is not going to help us. Statement 2 alone will not give us the answer. We can get multiple answers. And if you look at statement 3 again, quite a similar explanation is applicable, right? The statement 3 says price of the article was a multiple of 20. The price of the article is a multiple of 20 means what? Again, the same thing can be done. Of course, we have to choose the values in such a way that we always get a multiple of 20, but we'll get multiple solutions. So this also is wrote. And remember, when you're using statement 3 also, you should use only statement 3. You should not use data given in 1 and 2. You should forget that there are 13 currency notes. Remember, why didn't we consider that there are 13 currency notes? Like if you actually look at it, it is just a coincidence here that I've got 13 notes. I should not be doing this because don't misunderstand. When we did this statement 2 analysis, I did not keep in mind that A plus B plus C plus D should be 13. I think I should have chosen some other value. This is just a coincidence, pure coincidence that 2 plus 4, 6 plus 7 is adding up to 13. But actually we did not keep 13 in mind. This 13 was not in our mind, right? We can do something else also. Like for example, I should not be doing this. I can say is A equals to, let's say 4, and 4 means 4 rupees, and this is 8. So 16 rupees and 4 rupees, 20 rupees. And then this will be 4 and 8, 12 notes, right? So this will be 13 notes. You understand? Now if you see, again, you have to change the values accordingly here. This is not applicable anymore. But the point is, for statement 2 also, when I take A equals to 4, B equals to 8, C and D total 13. What are the total number of notes? 25 notes. So 25 notes can be considered because we are not worried about 13 currency notes. We don't know that there are 13 currency notes. When you're looking at statement 2, look only at statement 2. Don't consider data given in statement 1. Similarly, the same process is applicable for statement 3 as well. I mean, we don't have to do the whole calculation and analysis again, but statement 3 alone also will not help you. Right? Statement 3 alone also will not help you. So, I think independently 1, 2 and 3 fail to give the answer. Now, even if you go for combination, what happens? Even if you go for combination, you will not be able to get the answer. Even if you go for combination, you will not be able to answer. Because what kind of combination will you do? You will combine statement 1 with statement 2. Let me show combinations again in a different color, right? You combine statement 1 with 2. Or maybe statement 1 with statement 3. Now when you combine statement 1 with 2, what happens? Statement 1 says there are 13 currency notes. So we have to again take the number of notes in such a way that there are 13 notes. So go back to the previous solution that we had actually considered, right? 2 1 rupee notes, 4 2 rupee notes, and then if it is 2 plus 4 6, this should be 7. And based on that 2 4 7 only, we got two different solutions, 70 rupees and 80 rupees. Remember, I am considering 1 and 2 together. So statement 1 said that there are 13 notes. Statement 2 says the price should be a multiple of 10. When I try to do that, what do I get? 30 notes. How are the 30 notes distributed here? I have taken 2 notes of 1 rupee, 4 notes of 2 rupees and 7 notes of 5 and 10 rupees together. So 2 plus 4 6, 6 plus 7 13. This condition is satisfied. Statement 1 is satisfied. Statement 2 says the price of the article should be multiple of 10. For that multiple of 10 only we did all this drama earlier, right? You remember, we got two possible answers, 70 and 80. 70 and 80, two are possible answers. Right? Two answers are possible. Right? So even if I go for combination, it is not helping me get the answer. Similarly, even if you go for combination of 1 with, combination of 2 and 3 is anyway useless. 2 and 3 will not give you the answer at all, because 2 and 3 if you combine together, it makes no sense. Statement 2 says price of the article was a multiple of 10. Statement 3 says price of the article was a multiple of 20. So what? If the price of the article is a multiple of 20, automatically price of the article is also a multiple of 10. So 2 and 3 combination actually makes no sense. Right? This makes no sense at all, because one statement says price of the article is a multiple of 10. The other statement says price of the article is a multiple of 20. See, if the price of the article is a multiple of 20, automatically it becomes a multiple of 10 as well. So we get nothing out of 2 and 3 together. Now, the only combination possible is use 1 and 3 together. But even if you use 1 and 3 and you do analysis, you'll find that more than one answers are possible. Right? Even if you do a combination of 1 and 3, you'll find that more than one answer is possible. So overall, both 1 and, now go by options. If you go by options, what happens? Can both 1 and 2 give you the answer? No. Can only 2 and 3 give you the answer? Only 2 and 3 makes no sense, we have already discussed. Both 1 and 2 does not give the answer, this is the verification. Only 2 and 3 makes no sense, we have already discussed. Any 2 of the 3? Clearly no. Because when 1 and 2 cannot give the answer, how can you say any 2 of the 3? Only 2 and 3 can give you the answer? Achha, only 2 or only 3? Of course not. So I think if you go by options, it is much easier. Answer has to be option 4. Elimination. We are going for elimination. We have verified the combination of 1 and 2. We got two possible answers, 70 rupees and 80 rupees. 70 rupees and 80 rupees. Right? So both 1 and 2 together cannot give it. Here is the proof. Only 2 and 3 makes no sense, we have already discussed, so eliminated. Any 2 of the 3 is not correct at all, because when 1 and 2 cannot give, how can we say any 2 of the 3 statements can give the answer? Not possible. Only 2 or only 3 anyway is eliminated early in the beginning itself, right? Only 2 or only 3 cannot give the answer. So the only option left is option 4, which is other than the given options. So your answer for this question will be option 4. None of these options are correct. What is the perimeter of a rectangular field? What is the perimeter of a rectangular field? Now let me explain you the approach of a smart student. What will a smart student worry about? A smart student will not worry about the perimeter. He will try and understand, what do I need to find out the perimeter? You understand? See, remember that data sufficiency is not about the answer. Data sufficiency is about the data being sufficient to answer or not. So what do I need to find out the perimeter? You know that the perimeter of a rectangle is 2 times of L plus B. where L is the length and B is the breadth. Right? Perimeter of a rectangle is 2 into L plus B. So basically, for me to be able to find out the perimeter equals to 2 times of L plus B, and for me to find out the perimeter, I should know the two variables. What are those two variables? L and B. Right? L is equal to what and B is equal to what. So if any statement or any combination of statements gives me L and B, then I'm done. Don't try and substitute the values of L and B and then find out the perimeter. That's a waste of time. You're able to follow. Substitution in the formula is a waste of time. Don't substitute. Only find out what are the variables that we need to find out to be able to answer this question. So I am very clear now that L and B are the two variables that I'm looking for. So forget about perimeter or rectangular field and all that stuff. Just keep L and B in your mind. You have to find out what is L and what is B. Which statements can give you L and B is the question now. Now look at statement 1. You know the data sufficiency process, right? First, go statement by statement. First, check the individual statements. If individual statements fail to give you the answer, only then go for a combination of statements. So let's verify the individual statements first. Statement number 1. The area of the field is 2400 square meters. Area of the field is 2400 square meters. Now what is area? Area is L into B. So basically, statement 1 tells us that L into B equals to 2400. Is this enough to get the answer? No. Because there's only one equation with two variables. If there's only one equation in two variables, can you solve? No. I know what is L into B, but what is L and what is B is not known to us. So statement number 1 does not give you the answer. Jump to statement 2. Statement 2 says the diagonal of the field is 50 meters. What is diagonal of a rectangular field? Root over L square plus B squared. So root over L square plus B squared equals to 50. Is this enough to get the answer? No. Again, there is one equation which involves both L and B, but individually what is L and what is B is not known to us. So even statement 2 alone fails to give the answer, right? Now look at statement 3. The ratio between the length and the breadth of the field is 3:2. Ratio between the length and the breadth of the field is 3:2. So L is to B equals to 3:2. Now, if I know what is the ratio, will I be able to find out the perimeter? No. Or will I be able to find out what is L and what is B? No. L and B could be 3 and 2, could be 30 and 20, could be 300, 200, can be 9 and 6. There are infinite possibilities, right? What is known to us is ratio. So basically even statement 3 fails us to give the answer. So individual statements will not give you the answer. And now you'll have to go for combination. Remember, if and only if the individual statements fail to give the answer, then you got to go for combinations. Combination of statements. So statement 1 and 2, statements 2 and 3, statements 1 and 3, or maybe all the statements 1, 2 and 3. You're getting me? Yeah. Now, since we know that L and B, these two variables are needed, I basically need two equations. See, each statement here is an equation. This is an equation in L and B. Second statement is also an equation in L and B. And third statement is also an equation in terms of L and B. So I have got three equations and only two variables. Can I use any two of these three equations? Yes. For example, let's use 1 and 2. There are two equations and two variables. Can you solve? Yes. Now don't solve and waste your time. You know that in two equations and two variables, you can solve and get the individual values. So 1 and 2 is enough to get the answer. Similarly, I can also use 2 and 3 to get the answer. Statement 2 here is root over L square plus B square equals to 50. L is to B equals to 3:2. Two equations, two variables. Can we solve? Yes. And I can also use 1 with 3 to get the answer, because 1 says L into B is 2400 and 3 says L is to B is 3:2. So again, two equations and two variables. So basically, I can use any two of these three equations to solve for L and B. And once you get both L and B individually, you can find out the perimeter easily. So your answer to this question should be any two of 1, 2 and 3 are sufficient. Any two of 1, 2 and 3 are sufficient. Strictly speaking, option 3 is also correct, because it says only 1 and 2 are required. Yes, only 1 and 2 are required to get the answer. But at the same time, 2 and 3 can also give me the answer. And 1 and 3 can also give me the answer. So it is partially correct, I would say. Yeah. So those who have marked, see, basically what happens is you look at 1 and 2, you find that, okay, 1 and 2 can give me the answer. So you have marked only 1 and 3 are required. But also try and check the other possibilities. All the possibilities have to be verified. So those who have marked option 3 here are partially correct. What they have done is, they have done an incomplete solution. They have found that 1 and 2 are enough, but they fail to realize that 2 and 3 can also give me the answer, or 1 and 3 can also give me the answer. Same is the case with these guys who have marked option 4 as an answer. They found that 2 and 3 can give me the answer, but fail to realize that 1 and 2 or 1 and 3 can also give it. So these are all partially correct. Yeah. All three together are not required. All 1, 2 and 3 together are not required. I can use any two of them. So overall your answer should be option 2. Any two of 1, 2 and 3 are sufficient. Yeah. Maybe some of you have found that 1 and 3 are enough. L into B 2400, L used to be 3:2, so I can use 1 and 3 to get the answer. But 1 and 3 is not given in the options, so maybe you have marked option 5, none of this. But remember, any two of these three can be used. Alright? See what it says. In the following questions, you have to find out which of the following statements are redundant for determining the answer or can be dispensed with. Now, what does it mean? This means useless, or strictly speaking, not useful. Right? What is not useful in finding out the answer is the question here. The most common mistake, right, which students commit here is that they don't read this direction carefully. Usually this looks like data sufficiency, right? There is a question followed by 3 statements. Usual case is where we have to find out which of the statements are required. But what most students end up doing is, they don't read the directions properly and they find out the statements that are required, which is exactly opposite to what is asked in the question, right? The question says find what is not required. So it's very, very important that in such questions, data sufficiency, syllogisms, coded inequalities, read the directions, right? Are they asking us to find out what is required or what is not required? Are they asking us to find out what are definite conclusions or what are not the conclusions? What follows or what does not follow? Okay. Now here's the question. It says an amount of rupees 1500 is distributed among A, B, C who are wage earners. What amount does B get? So 1500 rupees is being distributed among A, B and C. A, B and C. How much does B get is the question here. Now how do you divide wages among persons? Wages among persons, it is divided based on the capacity. Basically, it is divided based on the amount of work done. Amount of work done by each person. Like for example, let's say if each person has finished equal amount of work, the total work is 1 unit. Total work always is 1 unit. So if each one of them has done 1/3, then they'll get 500, 500, 500. If A has done half of 1 unit, A will get half of 1500, 750. And B and C will get depending on how much they have done there. So basically, the amount has to be divided based on the ratio of the work done. Out of 1 unit of work, what fraction has each person done? Accordingly, you divide it. So let's first find out which statements are required to get the fractions of the work done. Then we will look at what is useless, what is redundant. First statement, A is twice more efficient than C. A is twice more efficient than C. Meaning what? If C can do the work in X days, if C can do it in X days, A will do it in X by 2 days. Remember, A is twice efficient. So if a person is twice efficient, the number of days required is half. Yes or no? If C can do it in 10 days, A will not take 20 days. Don't get confused. If efficiency is twice, A's efficiency is twice, meaning time required by A will be half. Yes or no? Time required by A will be half. So if C can do it in X days, A can do it in X by 2 days. That's the understanding. But anyway, that statement alone will not give us the answer. If C can finish a work in X days, A will finish the work in X by 2 days. How will we decide how much is the division of 1500 among A, B and C? Not possible. Look at the next statement. A and B works for 10 days, which is twice the number of days for which C works. A and B works for 10 days, which is twice the number of days for which C works. A and B works for 10 days, which is twice the number of days for which C works. Now from this statement, what do you understand? From this statement, the understanding is that A worked for 10 days, B worked for 10 days, and C worked for 5 days. Yes or no? Simple statement. A and B works for 10 days, which is twice the number of days for which C works. Now, is statement number 2 enough to get the answer? Well, some of you may say yes, because we know the number of days for which A has worked, the number of days for which B has worked, and also the number of days for which C has worked. But understand guys, here we only know about the number of days for which they have worked. It could be that the capacities are different. Just knowing the number of days will not help. We should also know the capacity of each of these persons, right? You cannot say that because the days ratio is like 2:2:1, we will divide 1500 in the ratio of 2:2:1. It will be incorrect. It may be incorrect. Because, see, 2:2:1 will be the ratio for division of 1500 rupees if they have got equal capacities. But is it mentioned anywhere that they have got equal capacities? They can be of different capacities also. First of all, don't remember what is given in statement number 1. You are not supposed to remember what is in statement number 1. Only look at statement number 2 independently. From 2, we know the number of days for which they have worked. But amount of work done is what? Remember, what is the work equation? Work is equal to the number of days for which a person works into the capacity of the person. That's what will give you the work, right? Men into days. Remember, work is what? Number of men into number of days. So A into number of days for which A works, B into number of days for which B works, C into number of days for which C works. A, B, C is nothing but the capacities of A, B, C. A, B and C there indicates the capacities of A, B and C. Right? Men days. That's what the idea, right? Work is proportional to men into days. Usually we say men into days, or it can be person into days. So men here indicates the capacity of the man. A's capacity into number of days for which A works. B's capacity into number of days for which B works. C's capacity into number of days for which C works. Anyway, the point is 2 alone does not give us the answer because it only tells us the number of days for which they have worked. We have no clue about their capacities. Point number 3. If C can do a work in 2 days, then B can do it in 3 days. If C can do a work in 2 days, then B can do it in 3 days. What does 3 indicate here? What does point number 3 indicate here? Point number 3 indicates the relationship in the capacities of A and B, C and B. Meaning what? Let's assume the work is W. Some work is to be done, which is W. C can do it in 2 days. Meaning work done is C into 2. Number of days is 2 into C. C's capacity. Which is equal to B into 3. So 2C is equal to 3B. That's what we get to know from statement number 3. Meaning indirectly it gives us the relationship between the capacities of A and B and C. It gives us the relation, like statement number 1 gives us the capacities of A and C, right? Relationship between the capacities of A and C, efficiencies of A and C. Statement 3 gives us the relationship between the efficiencies of B and C. Is this alone enough? No, not enough to get the answer. Because it only tells us the efficiency ratio. Like here, the ratio of C and A is 1:1/2. Here the ratio of C and B will be 3:2. Yeah? So 3 alone also does not give the answer. Now for us to find out the answer, what should we know? For us to find out the answer, we should know how much work has each person done. We should know the work done by A. Yes or no? We should know the work done by B. And we should know the work done by C. The actual requirement is what? How much time does B take? I mean, how much money does B take? Out of 1500, how much will B get? So for that, we should know how much work has B done. How much work has B done? Yeah, how much work has B done? Now, how can you find that out? Let's try. Now, since independent statements have failed to get the answer, see, 1 alone does not give us the answer, 2 alone does not give us the answer, 3 alone also does not give us the answer. Now, let's go for combination. If you go for the combination, what do you get? If I, let's say, combine 2 and 3. By combining 2 and 3, what will we get? By combining 2 and 3, will we get something? No. Yes or no? These values are respectively A's capacity into 10, B's capacity into 10, C's capacity into 5. See, I am getting this 10, 10, 5 from statement number 2. So statement 2 is definitely required. Can I do away with statement number 2? No. Statement number 2 is definitely required. Now, for me to find out the capacity of A, B and C, I will need statement 3 and I will need statement 1 as well. Because 1 gives me the relationship between C and A. 3 gives me the relationship between C and B. Only if I combine all these 3, I will get the relationship between A, B and C. Are you able to follow? Statement 1 gives us the ratio of A's capacity to C's capacity. Statement 3 gives us the ratio of C's capacity to B's capacity. We have discussed in the topic of ratio and proportion. That when you know the two ratios, only then you can combine them to get the ratio of the 3 persons. So for us to find out A is to B is to C, we should know all the data. I mean, we should know statement number 1. We should also know, we will need statement 1 and statement 3. Yes or no? We need statement 1 and we also need statement 3 so that we can get the capacity relationship. And I'm not interested in solving the problem. Remember, this is a question from data sufficiency. We only have to find out which of the data is required or which of the data is not required. So don't waste your time in solving the whole question now. Don't try to get the ratio of their capacities. The point you need to understand is number 2 is definitely required. Statement number 2 is definitely required because it gives us the number of days for each person. 1 and 3 are also required because only by using 1 and 3 I'll be able to get their capacity ratio. So capacity ratio is obtained from 1 and 3. Days are obtained from number 2. Meaning 1, 2, 3 all are required. All the 3 statements are required so that we can find out the amount that B gets. So can I say, is there any statement which is redundant here? No. He's asking us to find out which statements are redundant. If he says which statements are required, then all are required. Which statements are required, then all are required. Is there any statement that is redundant? No. There's nothing which is redundant. Can we do away with anything? No, right? Can we do away with anything? No. Why is that none of the options satisfy? He says only 3 is redundant. No, 3 is not redundant. 3 is required. 2 is also required. 2 is not redundant. 2 is definitely required. Either 2 or 3? No. Any 2 of them are redundant? No, definitely not. Only 1 is redundant. Is 1 redundant? Can I find out the answer using 2 and 3? Can we find out the answer using 2 and 3? See, 3 is not, we know that 2 is not redundant. 2 definitely is required. Statement 2. So option 2 and option 3 are eliminated. He's saying any 2 of them are redundant. We have already checked that any one statement cannot give the answer. If any one statement can give us the answer, then we can say any 2 of them are redundant. So this is also eliminated. 3 also is not redundant because that talks about C's capacity and B's capacity. Answer in my view should be none is redundant. Option 4 says only 1 is redundant. Why? How can I get using 2 and 3? No, I think all the options are wrong. 4 also is wrong. The answer to this question is none is redundant. None is redundant. Because to find out the ratio, both 1 and 3 are required. To find out the ratio, both 1 and 3 are required. So none of the statements is redundant. All the 3 statements are required.